Hello, I am Morgan, and welcome to my basic electronics class. Today we're going to learn about the XOR gate. The XOR gate is a basic computational device. It takes in two inputs and basically says if the two inputs are different, then the output will be 1. If they are the same, then the output will be 0. However, XOR differs from NAND and NOR in that it is not a universal computation. So, how could we build XOR using NAND or NOR? Let's take a look. Here we have an XOR gate built out from NAND gates. We can see that when the two inputs differ, the output is 1, and when they are equal, the output is off. We can also build this using NOR gates, although the output will be inverted. Now when the two inputs are equal, the output is on, and when they differ, the output is off. But this is a little complicated. What can we do to simplify this design? Let's take a look at some simpler designs to get started. Here we have a buffer, sometimes called a yes gate, and an inverter, sometimes called a not gate. The buffer simply allows an input signal to pass through it unchanged. It is very trivial, and it is just about equivalent to a bare wire, like this. Meanwhile, the NOT gate inverts its input. Input of 0, get out of 1. Input of 1, get out of 0. Now let's take a look at the controlled buffer and the controlled inverter. These are the same as before, but they have a second input on their side. When this input is off, the gate is closed. It's effectively a broken wire, like this. But when that input is on, then the connection is made and the signals can pass through. Now let's go back to our original NOT gate and yes gate from before, the ones that are not controlled. Here I've connected an input pin into the inputs of both the NOT gate and the yes gate. And we can see that if the input is off, then the top output will be on, and if the input is on, then the bottom output will be on. We're essentially selecting one of these two output lines to turn on with this single input. Let's combine our line selector with the controlled buffer and the controlled inverter from before. Here we have our line selector input, and it feeds into either the controlled buffer on the top or the controlled inverter on the bottom. Essentially, we're deciding which one of these two gates we want to be open. And then we have a data signal that feeds into both of these gates. So, in the top case, the signal passes through unchanged, and in the bottom case, the signal passes through inverted. Now, something to know about signals in Logisim is that they can have 3 states, well, kind of 4. The first is the undefined state, which is basically saying no signal. Then we have 0, and then we have 1. And the fourth one is an error state, which happens when you have conflicting signals on the same line. Right here we're trying to drive 0 onto this line, but we're also trying to drive 1 as well, and that creates an error. Now, the undefined state is essentially no signal, and you can kind of think of it like if I just disconnected this component, no signal is passing through from this component, which is basically the same as this. And thus, the important function we're looking for here is that 0 and 1 will override undefined states. So, let's go back up to our circuit. So what we can do to get the functionality of our XOR gate is to simply combine the output lines from our controlled buffer and our controlled inverter, like this. Now what we have is a circuit that uses one input to decide whether or not to invert another input. When this input is off, then this input passes through unchanged. And when this input is on, then this input passes through inverted. Which, if you'll notice, is the same behavior from our XOR gate from before. You'll see that these two outputs will always be equal. When the inputs are the same, the outputs are off. And when they are different, the outputs will be on. So you could kind of say that an XOR gate is a component that uses one input to decide whether or not to invert the other output. And this has a certain sort of symmetry to it. It doesn't really matter which input you think of as being the one that decides and which one is being inverted. If we say that this top input is the one that decides whether or not to invert the bottom input, then that works. And vice versa, if we say that the bottom input is the one that decides, then the top input is the one that's being inverted. Well, that's going to be all for today, class. I hope you feel like you learned something, and I hope you remember that you can do wonderful things, you deserve kindness, and I hope you have a good day.